Hello to all. In continuation of 8051 series, today we will discuss the pin diagram of 8051 microcontroller in detail. Yes, so regarding this is the pin diagram for 8051 microcontroller. This is a 40 pin IC. So these 40 pin are assigned as 1 to 20 pins are there and 21 to 40 pins are there. Basically, the main function of this 8051 controller is defined by these ports. So it having the 4 ports, the port 0, port 1, port 2 and port 3. So out of these 40 pins, the 32 pins are consumed by these ports. Okay, and the remaining 8 pin are as the one is the VCC, this is used for the supply, and the another one is the ground, and the next is two pins are used for the crystal oscillator, and another one is used for the reset, and the remaining two pins are EA external access, and this one is the ALE. Yes, so this ALE is what is nothing, just the address latch enable signal. So in this lecture we will see the function of each pin one by one and what is the importance of a particular pin function. Yes, so first we will move towards the input output port. As I have already told you, 8051 has the 4 IO port. IO port is nothing, just an input output port, or we can say these are the general purpose port. So port 0 is defined from pin number 32 to 39, and basically it is also accessed as for the programming purpose P 0.0 to P 0.7. It means it shows the pin number 1 for the port 0, and this one shows the pin number 8 for the port 0. Similarly, the port 1 is the port 1 pins are from pin number 1 to 8 and defined as P1.0 to P1.7. Similarly for the port 2 and the port 3. So the port 2 having the pin number is 21 to 28 and port 3 is from 10 to 17. Each port has a size of 8 pin or the 8 bit. Okay, so whenever you have to access this port through the programming, then how we write the port pin. So this is the example through which I want to define how to write a particular pin for a 8051. For example, suppose you want to write down the port 0 pin, then then how to write it actually. So this one is what P0.x. X is what it shows the particular bit or particular bit of the particular port. So P1.x, P2.x. So X is what? X is basically define the bit. It is a LSB bit. It is a bit next to LSB or whatever. So P0.0. This is what it shows the bit 0. That is the LSB of P0. Similarly, P0.7 is what? This is a bit number 7. It means it shows the MSB of P0. So all these 8 bit form a byte, or each port, port, that is a port 0 to 3 are used as an input or output port, or we can say these are used as a bidirectional port. So in the next slide we will discuss the function of each port in detail. Yes, so first we discuss the port 0. Of course, the 8051 is having the 4 port, that is denoted as port 0 to port 3. So port 0, as we have already discussed, it consume or occupy the pin 32 to 39, and this port are basically the bit accessible, so we can control individual bits separately. Is it okay? Actually, what do you mean by this? To access this port are bit accessible, so we can control the individual bits separately. It means that we can program the each pin separately. So this is actually basic difference between the microprocessor and microcontroller. In case of the microcontroller, we have to do the programming as a bitwise or bytewise, whereas in case of the microprocessor, we do the programming only as a bytewise. Since this port, all ports are as a iBio port, it means it is used as an 8-bit read and write operation. So these are the general purpose port, or basically all these ports that are used for the 8051, they are a multifunctional and multiplex port. So this port 0 is also act as a low byte address and data bus for the external memory design. Got to this point? The function, the one function for this port is what? This is used as an iBio port. iBio port, it means it is used in a read and write operation for the general purpose. But what about the another function this port is? This is also used as a low byte address and data bus for the external memory design. So this is the another function. So the port 0 is used in a multiplex form. Yes, and the next port is the port 1. Of course, this is also an iBio port. Okay, iBio port, it means it is used as a read and write operation as a journal purpose, but the specialty of this port is that it is not have any other function multiplex into it. It means this port is not used as a multifunctional port, except this port 0, port 2 and port 3 are used as in a multiplex form, but this port 1 is not used as a multiplex form. So due to this, whenever we have to design any application and want to use some port, so the first option is to use this port actually, because it because by using this the system function is not harm actually. Is it okay? So whenever any application demanding a port, so the programmer or user goes to this port that is called the port 1. So due to this multifunctional is not available, so multifunction is not available. Okay, so due to this process or due to this function, we can program this port easily, and using this port, other function will be multiplex. No other function will be multiplex, and with the help of this or with the use of it, we should not harm any other system operation. Okay. Yes, after the port 0 and 1, the next port is the port 2. Of course, the port 2 is what? Again, this is also a 8-bit read-write port that is used as a general purpose iBio port, and this port occupy the pin from 21 to 28 and written as similarly as we have already seen P2.0 to P2.7. So again, this port is also multifunctional. Remember one thing, there is a difference between the multifunctional port and the multiplex port. In case of the multifunctional port, it means it is behave now one time it behave as in a different multifunction, it means it perform the number of functions. Okay, multiplex, it means one time it is work as in a different task, and another time or another condition is work as an other operation. So again, this is a multifunctional port. The one function is used in an iBio port, then the another function is what? It also provides the higher order address bit for the external memory design. So what is the difference? What happened actually? In case of the port 0, the port 0 is what? Basically the port 0 is used for the low order address bus and the data bus, but the port 2 is used as a higher order address bus. Okay, so this is the one function. And another function is what? It also uses the read write operation for the general purpose. That's why I have to return a note here. Since port 0 gave the lower order address bus and the data bus, and this port 2 gave the higher order address bus. Basically the address bus is a 16-bit address bus. So the lower order is provided by the port 0 and the higher order is provided by the port 2. But what happened in case of 8051? It is a 8-bit port. So how many bits are required for the data purpose or for the data? So it requires only the 8-bit. So port 0 is having the two function. One is for the lower order address bus and the another one is for the data bus. So, and what happened in case of port 2? It only provides the higher order address bus. There is no any function related to the data bus. So therefore, for memory connection, two port, the port 0 and the port 2 will be used. Got to this point? Whenever you want to connect some external memory with your 8051 microcontroller, so the two ports are responsible. These two ports are port 0 and the port 2. With the help of the port 0, we can get the lower order address, and with the help of the port 2, we get the higher order address bus, higher order address bit. Yes, so next port is the port 3. Again, the port 3 is a multiplex and the multifunctional port, and the alternate function for this port are as given below. What happened in case of this port 3? This is a very important port or important port pins that we have to discuss here. Pin 3.0 or P3.0 is used for the serial input port, or we can say this is used for the receiving purpose, receiving data, and the P3.1 is used as a serial output or used as a for the transmission purpose. So these two pins are used for the serial communication. Similarly, P3.2 and P3.3 is used for the external interrupt 0 and external interrupt 1, and 3.4 and 3.5 is used as a external timer input 0 and external timer input 1. And of course these two pins are also important. These one are P3.6. this is used as a write purpose. And what do you mean by the write signal? It means external data memory write stop. And the 3.7, this is used as a read purpose. It means external data memory read stop. So again the question is, if it is used for the external data memory write or the external data memory read, so what about the internal data write or the internal data read? So as we have already discussed, all the port are used as an iBio port or the read and write port. So that function is used for inside the microcontroller. For inside the microcontroller, when we want to perform the read and write operation, that is performed by the port 0, 3, port 1, 2, etc. But whenever you want to connect with the external memory, at that time when you want to perform the read and write operation, then these two pins are responsible. Yes, and the next part is how to access the particular port actually. So we can access the port, that is the iBio port, port 0, 1, 2 and port 3, with the help of the name of the port, that is the port 0, port 1, port 2 and port 3, or another process for accessing this particular port in a programming. This is the address. So there is a different addresses that is used for with the different port. For example, port 0 are defined as at the address of 80287. Similarly, the address for port 1 is from 90297H. For port 2, the address is from A0 to A7H, and port 3, the address is from B0 to B7. So what do you mean by this thing? Here I just write down one example. Suppose when we want to set a bit of port 1, then there is a two method for writing this operation. For example, if I have to write down here the set bit P1.0. so of course this function is accessible, this function is what, and what is the alternate of this function is, or this instruction is, you can also write down the set bit. Set bit is what? This is nothing, just the instruction that is used for the 8051 microcontroller. Either you have to write down this set bit 1.0, or you have to write down this set bit 90. Basically this 90 is what? It denotes the first bit of the port 1. Is it okay? 90 is what? This denotes the first bit of the port 1. What is the 91? 91, it denotes the second bit of the port 1. Similarly, what is the 92? It denotes the third bit of the port 1. So 90 denoting the first bit, 91 denoting the second bit, 92 denote the third bit. So 80 to 87, it consumes the 8 bit here. Similarly 90 to 97, again it consumes the 8 bit for this port 1. So what is the alternate of this set bit P1.0 is? So this is the alternate of set bit 90H. So this function and this function, these two instructions are performing the same operation. Yes, till now we have to discuss the 32 pins of 8051. Next important pins of 8051s are that we have to discuss, in which the first one is a PSEN. PSEN basically implies program store enable. This is a active low pin. Active low pin, it means it is read out as PSEN bar. Okay, so it is activate when the low signal is applied here. Yes, so this is an output pin, and basically it is used for connecting the external ROM. Whenever in case of some series or some version of 8051 microcontroller is not having the on chip ROM, and when we want to connect some external ROM, so this with the help of this pin we can connect the external ROM with the microcontroller. What the next pin is? This is the ALE. ALE implies the address latch enable. This is the pin number 30. Basically it is used to latch the address on address bus with the help of the port 0 and port 2. Okay, as we have already discussed, the port 0 is what? Port 0 is used for carrying the lower order address bus, lower order address data bits, and the port 2 is used for carrying the higher order address bit. So with the help of these two ports, we can latch the address on the address bus. Yes, and the next pin is what? This is the pin number 31, and this pin is EA pin. So this EA pin is implies the external access, and this is the active low pin. Actually, what's the basic difference between the PSEN and the EA pin is that in case of PSEN pin, whenever we want to extend the ROM, then we move towards this pin. Whereas what happened for the 8031 and the 8032, these are nothing, these are the different version of the microcontroller that having there is a no on chip ROM. So whenever you want to connect the ROM externally, so this pin is used. Actually this is not used for Of course it is used for extending the ROM, but this is used for in case of the 8031 and 8032 where the on-chip ROM is not available. So we want to connect the external ROM with the help of this pin. That's what is called the external access. Okay, so this pin is connected to the ground to indicate the code is stored externally. So whenever you want to get activate this pin, so this pin is connected to the ground. But if we are trying to access only internal memory, then EA bar line will be made high. Okay, internal, whenever we have to work with the internal memory, then generally it is connected to high. Otherwise, when you want to access the external memory, then this pin is connected to the ground. Yes, and next pin that are used for the 8051 controller is these are the VCC pin is there. The pin number 40 define this VCC. VCC provides the supply voltage to the chip, and this having the voltage source of the 5 volt. And pin number 20, this is the ground pin. And the next one is pin 18 and 19 is used as a crystal oscillator pin. Basically it is used for providing the external clock. So for this connection there are the two circuitry. Here we there is a two circuitry for generating the external clock. The one is with the help of the crystal oscillator, and the second one is the TTL oscillator. So in the next slide we will see how to connect the crystal oscillator and how to use the TTL oscillator. Yes, this is the circuit diagram for the connection of crystal oscillator with the 8051, and this is a circuit diagram for the external clock source. So what happened whenever we have to connect the crystal oscillator? So that this one is the crystal oscillator. So this crystal oscillator is connected between XTAL2 and XTAL1 pin. Okay, and these oscillator pins are connected with the help of these two capacitors that having the value of 30 picofarad, and after this connection this is connected to the ground. So this is the connection for the crystal oscillator, and taking the output from XTAL2 that gave the operating frequency for this 8051 microcontroller. And what is the another method for connecting the crystal oscillator to the external clock source? So this one is this is the circuit diagram. Here what happened, the XTAL2 pin is unconnected, this is not required. Okay, and the XTAL1 pin is connected to the external oscillator, and after that connection it moves towards the ground. So there is a two structure or the two way for connecting the crystal oscillator with the 8051. Either we have to use this one or we have to use this one. If we using this one, then both pin are used, but we have to use this process. In this case only XTAL1 pin is used, whereas XTAL2 is not connected in this case. Yes, so after the discussion of the crystal oscillator, now we will move towards the calculation of machine cycle. Basically 8051 is operated on the frequency of 11.0592 megahertz. So we will see how to calculate the machine cycle for 8051 microcontroller. Okay, for example, there is a question: find the machine cycle for crystal oscillator that having the frequency is 11.0592 megahertz, and another crystal oscillator is that having the frequency of 60 megahertz. Remember one thing, what you want to calculate here. Here we want to calculate the machine cycle. So when we calculate the machine cycle, then what is the process? Actually, a frequency that is given for the question, it just divided by the 12. So in this question, the first part, the crystal oscillator frequency is what? This is the 11.0592 megahertz. So you divide this frequency by 12 and get the value. And what about the machine cycle? Machine cycle is what? The reciprocal of this value. So 1 by 921.6 kilohertz. So this is equivalent to what? This is the 1.085 microsecond. So this is the machine cycle with this crystal oscillator frequency. Again, whenever you want to calculate the machine cycle for this crystal oscillator frequency, then there is the same process. Whatever frequency you have to given, you divide that frequency by 12 and get the value and take the reciprocal of that term. Is it okay? So the machine cycle for this crystal frequency is what? This is equivalent to 1 over 1.33 megahertz, and this is equivalent to the 0.75 microsecond. So now the question is that why we have to divide each crystal oscillator frequency by 12. So remember one thing, in case of 8051 microcontroller, machine cycle consists of the 12 clock pulse. I just repeat the same line. In case of 8051 machine cycle, in case of 8051 microcontroller, machine cycle consists of 12 clock pulse. ओके 8051 में जो मशीन साइकिल है वो 12 क्लॉक पल्स कंसिस्ट कर रही है. सो ड्यू टू दिस वी हैव टू डिवाइड द क्रिस्टल फ्रीक्वेंसी बाय 12. Okay, got at this point? So each and every given crystal frequency is divided by the 12, and you all know what is the definition of the machine cycle, what is the definition of the instruction cycle or the T state. We have already discussed these terms actually. So whenever you want to calculate the machine cycle, the given frequency is divided by 12 and take the reciprocal of that one. Yes, and the next pin for 8051, next and the last pin for the 8051 microcontroller is, this is the reset pin, and this pin number is 9. It is what? It is an input pin and active high pin. Active high pin, it means what is activated when it connected to the high. So in normal condition it is connected to the low, it means it is connected to the ground. The high pulse must be high at least 2 machine cycle. So whenever this reset function is going on, so it is going on for the 2 machine cycles. Okay, and what is the importance of reset pin is that normally it is active. It is active low pin, but whenever you want to require to activate this pin, then we have to connect it to the high. And when the power is on, then this pin, with the help of this pin, the circuit is reset. So it is a power on reset. Upon applying a high pulse to reset, the microcontroller will reset and all value in register will be lost. Okay, so this is the important part. Whenever you have to do the reset process, then what happened? All the value in the register will be lost. So what happened when you push the reset button for a microcontroller, then all value are lost, all become 0 except this stack pointer. So this is the important part for this 8051, that you should have to remember. The program, whenever the reset pin is pressed, the program counter goes to the 00, accumulator is again 00, register B is 00, PSW program status word, but it means the flag register is again 00, DPTR is 00, all the RAM area is become 0, but the stack pointer is having the value after on reset. This is the 007. So this is the important part of this 8051 microcontroller. Yes, and this is the circuitry for performing the reset operation. So there is a power on reset circuitry. So what happened in this case? these two pins are the X1 and X2 are the crystal oscillator pin. So here crystal oscillator is connected with the help of these two capacitor, and these two capacitor are shorted and connected to the ground, and the EA pin is connected to the VCC. So this is the requirement for the circuitry for the reset. So whenever you push this button, it means you do the process of reset, and when that reset is going on, then all registers values are 0 except the stack pointer. So this is the reset circuitry for 8051 microcontroller. So that is all about the pin diagram of 8051 microcontroller. If you have any problem, any query regarding this, then you can ask through mail, through WhatsApp, etc. Okay, so thank you.